Hello, everybody. Today I'm going to be showing you what an algorithm is and how we use an algorithm in Roblox, for example. So let's go ahead and get straight into it. So we're in Roblox Studio, and we're going to go ahead and create a script. It can be a modular script if you want it to be, or a local script. It's just personal preference. For the time being, with this tutorial, we're just going to do this script inside a server script service. I'm just going to call that our al or al whatever. And that's just going to be for just the name of our script. So we'll go ahead and I've gone ahead and written out a few instructions here. So what is an algorithm? For one thing, well, an algorithm it tells the computer a set of instructions, and then there's multiple reasons you can use an algorithm to perform like high calculations. You can do multiple calculations with an algorithm, and like how do we actually create an algorithm in Roblox? Well, that's what this video is going to show you how to do. Okay, so for the purpose of this video, we're going to be telling our algorithm that it's going to create a part, and we're going to go ahead and define what our part is / what it should look like. We're going to then tell it to perform some math, give it some instructions on what we need to do, and then we're going to provide our algorithm with our functions so that when it's called, it will create our object. So let's go ahead and begin by starting the functions. Create object. So let's go local function, and then we'll do create object. Create object. Objects. Okay, so let's go ahead and create our object. For the purpose of this video, we're just going to go ahead and use a new part. So we'll go local new part. We'll just go for local part, and we'll go for equals instance dot new, and then we'll go ahead and open that into curly brackets and go to part, and then we'll parent that to the workspace because that's where we're going to be working. Okay, so then we can go ahead and drop down a few lines, and we can say new part dot name equals, and let's say I am part. I am a part as an example. Okay, and then we'll say new part dot size is equal to vector3, and then we're going to say vector3 dot new, sorry, and then we're going to say our size. For the purpose of this video, we're just going to go 2 by 10 by 2. And then we're going to go ahead and do the color. So we're going to say new part dot brick color equals brick color. So brick color dot gray, for example, just as a default thing. Okay. And then what we can do is because it's going to be passed back to our algorithm, we're going to go ahead and return that new part. There we go. Now that's going to error out currently, but that's because we haven't done the rest of the script. So let's go ahead and move on to the next function we're going to need. So we said we're going to create a part, we're going to tell it to perform some math and give it some instructions. So let's just do a few examples here. For one of the examples I'm going to show you today is we'll do local function, change part color, just like that. And then we'll go ahead and put a part in there because we're going to be passing a part through this function, and that's what we're returning up here. We're returning our object back to our algorithm, which will be further down. So let's go ahead and print the part chosen is, and then we'll go ahead and we'll say concatenate it with toString, open brackets, and then we'll say part.name. Okay? And then we can go ahead and we can end that function there. So that's all that function needs to do. It doesn't need to do anything else. So then we can say local function, not function. And let's say we'll do change part color. Why not? Local function, change part color. Could be something as simple as that. Just one little set of instruction, that our algorithm is going to need in order for it to do the work. So let's go ahead and now we'll go ahead and write that function now. So we'll say print parts, default color, color. So let's do the parts, the parts, default color was, and then we'll do a concatenation and we'll do toString part dot brick color, just like that. Okay. And then we can go ahead and we can say part dot brick color, just like that. And we can say is equal to brick color dot random, okay? Because we're going to change it to a random color. All right. And that's what we're going to tell our algorithm to do. And then we can say print parts. So we said the parts new color is, the parts new color is, and then we can say, we can concatenate that, and we can say toString part dot brick color, just like that. And what we've done there is we've just defined two sets of instructions for our function. Well, three sets of instructions. We're going to tell our algorithm to create an object. And with that object, we are going to tell it to change the parts color. We're also going to tell it to change. I've done the change part color twice. I meant to say get part name. That's what I meant to say. Sorry. Get part name. Get part name. Name. Okay, there we go. That's what I meant to say. So yeah, we said change the parts color and once get the parts name. There are two sets of instructions that our algorithm is going to learn. So let's go ahead and create our actual algorithm. So let's go ahead and do a local function, just like that. And then we can say our alg, for short for our algorithm, okay? And then we can say our local object, object is equal to create part, okay? And that's going to return our part as an actual passable variable, which is going to be great. So just going to show that that's about right. Yep. Okay, yeah, there should be no issue there. Okay, that's going to do that. So we can come down here and we can say, what we're going to do. Okay, we're going to now say change part color, and we'll pass in our object through here. Okay, just like that. And then we can come down here and we can say we want to get the part's name, so get part name. And then we can pass the part through here as well, which is the object, of course. Okay? And as you can see, that is our function created. Now I'm just going to check that why that's returning an error, because it should not be returning an error as far as I'm aware. Have I spelled something wrong? Let's have a look. I don't think I have. There'll be some sort of issue. Let's just try and run it and see. So for this purpose of this video, what we're going to do is we're going to, before we change the part, we're going to wait. We're going to wait like I don't know. We're going to wait like 1.5 seconds before we change the part's color. Okay. So what we can do now is we can call our algorithm. So we'll say our algorithm, just like that. And then if we go ahead and we press run, okay, we can see that we've got the actual issue here. So it sets an assignment on the function call. So the new part is equal to instance.new and it's the parent to the workspace. Yes, okay. That is correct. And I have got that on this one. So what I'm going to do is I'm just going to copy this. I don't know if I've spelled something wrong there. but we can just copy that and paste it in again. It's exactly the same. I probably spelled something wrong, knowing me. But anyway, let's go ahead and redo that. That's not what I wanted to do. That's what I want to do. Okay. So now if we go ahead and run it, we can see that we do get a part. Okay, let's just get rid of the spawn point for the time being, so we can see our part. Maybe we should anchor our part. That's what we should do. So let's go ahead and do new parts dot anchored is equal to true. Let's go ahead and press play. So as you can see, our new part's there, and we can say part chosen is I am a part. Yeah. The default color was medium stone grey. Its new color is medium green. And that is our algorithm. Our algorithm has decided that it's going to create those, it's going to do those set of instructions that we've told it to do. And that's an algorithm. Now we could call that algorithm 1,000 times, and as long as we've got the instructions within that algorithm, it's going to run it. And that's just what an algorithm is. Let's go ahead and do one more function just for the purpose of this video. Let's go ahead and say, not another algorithm, I mean another set of instructions. So let's do local function. And I will say get part. No, let's do like I don't know. I'm going to challenge myself. Okay, I'm going to go ahead and pause the video here, and I'm just going to come up with an idea for what I'm going to do in terms of like this next part. Okay, so what I've gone ahead and done is I've written a simple script, so not a simple script, but a simple function that says get distance from player. And what we're going to do is we're going to, as you can see here, it says for I, V in pairs, game, get service, players, get children. So we're going looping through all the players in the game, checking to see if there is a player in the game, and then we're going to check to see if they have a character. If they do have a character, we're going to get the magnitude of the character from the part. So we're going to test to see if the player is great. Well, if they are greater than 2 blocks away, then we're going to say the player is not in range, right? But if the player is like far away from the player, so the part is far away from the player, it's going to print the player is not in range. Like I said, this is all part of our algorithm, and that's what the purpose of this video is for. The purpose of this video is just to teach you how an algorithm would see these instructions and what is an algorithm. So we go ahead and we run this, go and clear the output. And as you can see, if we press play, we've got the part chosen is I am part. The part's default colour was medium stone grey, and the part's new colour is really black. The player is not in range because, let's just say for an example, it probably have it should do opposite, but let's say the player can use this when they're not next to it as an example. I probably should just flip them around just as an so it's not so confusing. Let's just do that. Why not? Let's do this. Actually, we can just change this if it's less than 2. No. So if it's greater than 2, yeah. We'll just say yeah. That should do. I don't know what I'm saying. Yeah, so many times. Right. No, here we go. Let's go and paste this down here, and then we'll go ahead and just change it. Because what we're going to do is have it so when they are close to the part, it's going to say the player is in range. Just like that. So now when we press play, it'll say the part is in range. Let's give it a second to load. There we go. Okay, yeah, so you see the part is in range, and so it says that the player is in range. But let's go ahead and move a part when it spawns in. So let's say the part's position, so say new part dot position is equal to vector 3, and we'll say dot new, and let's just say it's like, I don't know, 5, 1, yeah, that'll do for now. Okay, I'm going to go ahead and press play now. We should have a completely different result now. And there we go. So it says the player is in range. Okay. That's because they're still within range. So we need to go ahead and we need to. It's not in range. Yeah. The greater it's less than 2. Sorry, that's what I meant to say. So if the player is less than 2, they're greater than 2, then great. So as you can see there, yeah, the player is not in range. But as soon as we move the part back into back into its range, it should, like, if we just get rid of this entirely I'll put it to 0, 0, 0, or just delete the thing entirely as an example. We'll just comment it out for now. Why not? We go ahead and press play now. It will say player is not in range. Just like that. Now, you get the idea that I'm getting across. Okay, so if the player is not in range, then it will basically tell you that. But that's what our algorithm's doing. The algorithm is doing all the calculation for us. We've got our functions up here, and instead of us calling our functions individually, it's just going to call them all in one go, which is what an algorithm is. It's a lot of set of instructions that the computer recognizes as code. So thank you for watching. This was all the I wanted to say in this video. So thank you for watching. My name's Ryan, and make sure to like the video, subscribe, and I'll see you guys in the next video.